Now let's factor out the greatest common factor from some polynomials. So how we do that, remember that was kind of reversing the multiplication process. So let's see what we have that's common to both of these terms. Looks like what's common to both of these terms would be a 5. So let me rewrite these as a 5 times an x squared plus a 5 times a 6. I can see 5 is common to both of those, so I'll reverse the process by factoring out the 5. And when I do that, I'll put the parentheses in remaining, and what's left, I'm going to catch the x squared and the 6. And I factored out the greatest common factor, and I'm left with 5 times x squared plus 6. And you can verify that's true if we go through the multiplication route now. If we multiply this through, 5 times x squared produces a 5x squared, and 5 times a 6 produces a 30. Now I have 18x cubed plus 27x squared. What do we want to factor out? Well, ideally you want to factor out the greatest common factor that you can. And so the greatest common factor in this one appears to be 3. Can I factor out a 3 out of both of those? Yeah, I can. But that's not the greatest common factor. The greatest common factor is a 9. So, and it's a 9x squared. So let's rewrite those. So it's 9x squared times a 2x plus a 9x squared times a 3. So I see that a 9x squared is common to both of those, and it's also the greatest common factor to both of those, which allows me to factor them out from both terms. So I'm left with a 9x squared times what goes into parentheses. Parentheses are very important here. What's left is a 2x and a 3, and it's a plus 3. So that is the factorization of that polynomial. Now, what if I didn't realize it was a 9x squared, but maybe I factored out maybe a 3x squared? Well, then I would get something like a 3x squared. And then what would be left would be a 6x plus a 9. Yeah, a 9x square, yeah, and 9x, whoops, just a 9. Okay, I factored it, but notice that what's remaining, the 6x plus the 9, those still have a common factor in there of a 3. So I would need to factor again, and that would be a 3x squared. I'll leave that alone. The 6x plus a 9, I'll factor another 3 out, and then what's left would be a 2x plus a 3. And then I would multiply 3x squared times the 3, which would give me the 9x squared times 2x plus 3. Now I did that extra part because sometimes we aren't able to recognize what the greatest common factor is. We just recognize a common factor. That's fine, start with that. But when you're done, check it again to see if you can factor a second time, or maybe even a third time. We can also find the greatest common factor of a polynomial that has 3 terms to that. So we need to be looking a little bit more farther out to find out what the greatest common term is. So 16, 12, and 4, I'm looking at those coefficients first, and it looks like the greatest common factor would be a 4. And in the variable terms, x to the 5th, x to the 4th, x to the 3rd, it looks like x to the 3rd would be that. So out of each of these terms, my greatest common factor is a 4x cubed. And then what's left would be a 4x squared here. Four x cubed times a 3x produces a 12x to the 4th. And then a 4x cubed times what? Times a 1. I better have that in there. It's kind of a placeholder. So now that we factor out the 4x cubed, we'll factor 4x cubed out of all those terms. And then what's left, I have to make sure I leave in the parentheses. So what's left here is a 4x squared minus a 3x minus has to be a 1. I can't leave that one blank. And the reason why, imagine if I went through the multiplication process this time and multiplied across. 4x cubed, well, distributive property, multiplication, 4x cubed times 4x squared, That produces a 16x to the 5th. 4x cubed times a minus 3x gives me a negative 12x to the 4th. And then 4x cubed times a negative 1 gives me a negative 4x cubed. So see how that negative 1 or that 1 is very important to have? Because if I multiplied it back, I need to get that 4x cubed back to its home position. So this 1 right there, I hope you see the value of why that's important. Now in this one, I have 3 different areas to look at for greatest common factoring. The coefficients, what's the highest coefficient that goes into each of those? And it appears to be a 9. Then I have to look at the x terms, x squared, x, and an x. Looks like x is the greatest common factor that goes into each of those. And then I also have to look at the y terms, y cubed, y squared, and a y. So it looks like a y is the greatest common factor on that one. So just to help me out, the greatest common factor would have been a 9, x, y. And then if I did that from the first term, that'd be a 3x squared, y squared. I factor in 9xy out of the second term. Then I'm left with a y. And if I factor in 9xy out of this last term, I would be left with a 9. So now I see that there's a greatest common factor in 9xy in each of these 3 terms. So let's pull that out and then find out what remains in the parentheses. We have 3x squared, y squared, minus a y, plus a 9. And there's no more common factors between those 3 terms, so I completely factored that polynomial as far as it can go.